where things are going on with Scala everywhere. Data engineering frameworks like Spark and Kafka and Flink, and those technologies being created with the Scala. So what I would like to do is to set the context differently for this entire workshop, entire technology of month, is that we will not go with the presentation style of that this time. So the first most important thing which I have learned with my team, working with the Axion Labs for at least 4.5 years, leading a couple of largest big data team in Axion Labs, is to inspire and simplify the functional programming language with Scala for them. So it's not to make the things complex. It's not about to make things confused, but to make simplification. What is needed, only focus on that and explain that things in that manner, right? So what I have done is to create a simplification of the code in Scala and explain you from the start. The pre-requirement for this talk is nothing, simplify nothing. I mean, whether you don't know programming language, should be fine. So we'll start from very scratch, and then upcoming session will go in very advanced topics, right? So let me start with why we talk about functional programming, right? The first thing about Scala. What is Scala? Scala is a functional programming language created by Martin Odersky in Switzerland EPFL laboratory. So Scala runs on JVM. So obviously you need JVM. That means that without JVM machine, you can't run Scala as a programming language. Now Scala is kind of hybrid for now. I mean, so you can write your code as object-oriented programming, plus you can write your functional programming code also, which means that technically you can run your Java code in Scala also, because it runs on JVM, it creates the bytecode, and it goes in same manner, right? But some of the best practice tools like IntelliJ will not allow you to run your code in Scala with in Java with the Scala project. So Scala is not only functional, but it can help you to write the code in object-oriented programming. So technically, if you compare with other purely functional programming language like Haskell, will not allow you to write any code which is object-oriented programming, right? Which means that you can't have an interface, you can't have you can't have a class, and you can't do inheritance, you can't do those polymorphic operations on top of that. You can only apply the purely functional aspect on that Haskell kind of programming language, right? So think like if you are creating like web service or microservice where you need to have some implication of object-oriented programming, and then each idempotent unit of the code, you want to write it as a functional programming aspect, you can write that code in such a way which becomes a highly powerful and tremendous performance-driven code when you talk about concurrent and asynchronous application. So yeah, this is all introduction about Scala, what you can do with the Scala and why Scala is used, right? Now, the question would be that where I should use Scala, right? Why can't I, if everything is answered by Java, why I need to go with Scala, right? So when it comes to distributed programming, when it comes to concurrent and highly asynchronous programming, at that time it is viable, and it is a very beneficial to use Scala as a programming language, because most of the enterprise platform that companies create use Scala for creating highly performance-driven applications and platforms, right? This is all about the kind of why we can use Scala and the intention behind using Scala for the enterprise. Now, coming back to the two things, right? We have procedural programming and we have functional programming. So how it differs and how we can understand that. When you talk about procedural programming versus functional programming, you think like that procedural programming will tell you do. I mean, you provide the statement that run the println, assign the variable to that, and then you get value to that. I mean, everything will become statement and it will be executed in sequence, right? When it comes to functional programming, you you will just describe that I want to do this, but you will not do that. You will describe in the steps, and when it comes to execute that, you will compose each function with each other and make sure that it has a highly immutable data structure. Now, again, coming back to why you need to use the immutable data structure, because it is thread safe, and Scala runs kind of green threads behind the compiler and create the highly concurrent and asynchronous execution model for you. So it generates the directed acyclic graph for you and find the dependency in between that and execute the code lazily. So generally, unless you create your Scala code as a procedural programming language, when you create functional programming language kind of code, it will compose each other and execute in a lazy execution mode. And how it executes. When I talk about using the procedural programming language in a functional programming language, those are known as a side effect. Side effect means what? Side effect means, let's say, if you are running any code and that gives interruption in between and that affects the compiler, right? That's called side effect. For example, the one thing that we need to remember in functional programming is that we will never throw exception. We will either succeed or we will fail. So if you have a code running, if you think there's something is failing, you will fail. So generally, you might see very less exceptional handling in the functional programming, because either you make sure it runs or either you say it failed in that way. So let it fail is what the functional programming aspect advice from the experts, right? So what are the features in the, let me share my screen, those notes I have, so you can also get that. I hope you can see my screen, right? So the features in Scala is that it is type safe. So that does mean it provides you type safety, in the sense you can do type evolution at runtime. So like Java also, you have types, right? It's not untyped. So at the compile time, you know, even though it's asynchronous, that what type is fits to that programming language. Let's say I should share my entire screen so you better can see the Scala here. So I'll go to Scala as a compiler here. You can just get Scala here. Let's say if I say, well, x is equal to 1, right? So here you see that it will do type inference and give you that x is integer, right? So this is just small example, but when you compose very highly complex functions with each other, it gives you everything as a value here. So even the function that you have, that can be created as a value here. So everything is a value here. Things like the immutable value, whatever you can execute that here. Second is concurrent, means Scala's backbone of the concurrence programming function is future. So Scala uses a future. That is, what is future, that we'll talk. But think right now is the future is concurrent data structure that can be used to compose many other functional block, and you can run that code block in parallel. It is resilient, means if you write entire abstraction of your code and then you think that in between something has failed, right, it has the ability to recover to the original point. So runtime you can define to go back to last stage from where it is then failing the execution model. It is asynchronous, means you can do two things. You can do concurrency and you can do parallelism together wherever you need. It is resource safe, means leaking the resources, right? Going to race condition, getting deadlock, those things you can avoid with Scala. Yeah, obviously it's testable. You can write your JUnit kind of test cases on that, and it's functional, right? Like as I said, you can have a functional programming aspect that we'll talk. What do I mean by purely functional programming language here, right? So, I mean, again, many people talks differently about functional programming. So everyone has different view on functional programming. What I mean by functional programming is specific to data engineering, okay? So we are not going into different aspect of creating own library with Scala or kind of that. So when I talk about purely functional programming, that does mean you don't have no exception, no casting and no nulls, no global variable in that, no serialization, safe type safe program, first class support for database you get, and you have few dependencies in between that. You can have a better debugging, and implementation is independent performance. So when you want to tune the performance of any code block, you should have an independent a code block, in the sense that you are not dependent on each other. You tune one function to give advantage to the other function in that way. So coming back to what is the rule number one for you is don't solve the problem, but describe the solution for that, right? And don't compute, but embed a compiled language into Scala, right? So you will not write the code which will directly execute the things without checking the dependency of each functions each other, right? And every single line is building description of the computation. At the end of the line, you create the entire workflow, and that will be translated and executed at the end, right? So think like you have directed a cyclic graph in a form of tree, and then you describe all the diagonal operation, and then once operations are qualified, in the sense there's no compilation error, you execute in the form of DEG, and then that execute in a form of lazily execution manner. So it is not computed in the compiler, but it is just described and validated that everything is correct to execute, right? So you get two kind of advantage, is that there is nothing called compilation error, and it is not executed. Second thing, when you execute, it makes sure it will run as expected without any unexpected error, right? So now shifting back to the code that that is written, okay, for you to explain some of the things. Yeah, so let's talk about collection types that we have in Scala. What kind of collections are there? Coming back to original question that I'm simplifying these things. We are not going in very advanced level. We will just make sure that what is there in the Scala and how you can use Scala from in the form of a beginner starting point. So this code will be shared with you. The talk will be shared with you. So let me define. We will. So in Scala, when you create the project structure, let's talk about that. How you can create the project in Scala. You can go to new project and choose Scala as a programming language. Use the SPT. Now SPT is a Scala build tool. The tool is like building the project, like how you use Apache Maven to build the Java project. Some people use Gradle to build the Android and the Java project, right? So same as to build a Scala project, you can use SPT. SPT itself is written in Scala, and that is preferred build tool for Scala people, right? Once you create that, it will just create the project structure, what you can see here. And most important part is build.spt. Here, where you define all the dependencies like you use in pom.xml when you work with Java, and build.gradle when you work with Gradle based project. And inside the project, you have the build.properties and plugins.spt. So build.property will have the SPT version defined here. So we are using 0.13.15, but right now you can find the latest version 1 point something. You have plugins. We are using SPT assembly plugin. So this plugin helps you to create the Uber jar, how you create in the Java here. So once you add this plugin, you will be able to get the jar which is executable for you. And then you have src main, same like Java, right? Package here you get here. So let me go back to first thing, collection library that I have created that. So if you want to create the list, and before that, yeah, same thing, package structure, scala.collection mutable. So there is a package called scala.collection. This contains two type of collection, immutable and mutable. As I said that we are not talking about now that how you can do functional programming, but we are talking about Scala now. Earlier, what I explained you is all about functional programming. So this will contain hybrid approach. Like you have the some of the code works as a functional programming best practice, and some of the code is just explain the Scala, how Scala works, right? So inside Scala.collection, you have two type of hierarchy. One is the immutable, and other is mutable. So there are data structure which can be changed if you want to do that way. And then you create object and class object name here. And once you have the this curly bracket, you have the def main. So similar like public void main, and you pass the argument and array string. Now you can have either this, or you can just remove this and have extend apps here. Okay, you can extend app. So once you extend the app, you don't need this main method anymore, because this interface gives you everything what you need inside that. So there's two ways to do that. One is either you write own main method or extend the app. So I'm just removing the own method, right? Now, what are the different type of immutable collections are there in Scala? That's what we will see here. So if you want to create the list, you will say list of integer and provide the list here, whatever type you want to give here, and then you will print here, right? So we'll execute this after that. If you want to have a list without specifying the type, like how we specify type integer here, right? You can just create a list of integer. And as I said earlier, Scala provides you type inference to you. It will automatically detect the type inference for that. And if you have array, you can create the array of integer and then provide the integer here, and then same method like array.length to find out the length. If you want to create the map, we have a map class, string and integer. You say the key is string and the value is integer, and you provide the map and say that key and value pair. Now you have the set here. The set can be with the same type of data type, and then you have the non-duplicate values for that collection type, right? So you can say value set. Now, one thing I haven't spoken so far is what is val and what is other things to go ahead with that. So val, when you find something as a val, it's immutable. Means I have created val x is 1. Now, if I say x is equal to 2, it will say exception, that reassignment to val is not guaranteed. That's not valid. If you want to create a non-immutable, means the value which can be changed, then you have to use var, where y is equal to 0, and then you can define y is equal to 1, and this will work here, right? So that's basic difference between both. Now, val is also lazily computed. It means when you define that, the value is computed for you and cached when you do well. But when you do where, it is a reassignment completely, that you can get the value wherever you need that, and you can do reassignment if you want to have that. So the execution model with Scala is the three types that you have. One is the well, that eager and saved in your compiler context. So when you do a lazy well, right, that's lazily and cached for you. So you can also have a lazy well. Let's say u and 0, right? So this is a lazy. I mean, the value is not defined here. You can see here. Whenever I call it u, at that time the execution model is computed and give you the value to you. So in earlier time, earlier execution model here, it won't allocate the memory, it won't allocate the memory address, it is just defined for you. Unless you execute, it won't execute that, right? And when you do def something, let's say define demo, and then you say 9, right? So this does mean that it is defined always lazy, but not cached in the memory for you. So when you say demo, it gives you 9. That's difference between three type of variable declaration, how you can do that, and what is the difference between that, right? So coming back to here, set. So if you want to explicitly declare the type, how you can declare is this way. You say value David, say value name, you say you want a string, and then the value is okay. So then you can also define explicitly if you want to make sure. The advantage with defining explicitly is that when you write your code in ID, it will give you analysis error that it can't accept that before you compile events, right? So in that way you can define that, because otherwise it won't understand the values unless you compile that. So if you say name and whatever you provide here, it won't accept here. I mean, it accept here, but when you use your ID like IntelliJ, you will not see real advantage over there. So that way, double colon is used to define the type of the variable here, which you can see here, like set. And then you can say mutable.set and provide the value here. And how you can create a tuple. So tuple in Scala is limited to 22 till Scala 2.12, sorry, 2.11. So in Scala 2.11, you can have only 22 tuples. And how it works is that you can say tuple2 and the type inside that, and then you create tuple 1 and 2. If you want to create 3 tuples of different type, then you have to say tuple 3, create integer, string, and double, and then you can create the tuple the way you want. Now, if you want to create a mutable collection, then you have to use list buffer here, which comes from mutable data type, and then you say mutable list of integer, and then you create the list of buffer, and then you want to add the value here. So plus equal to means add the value to the existing value that you have, list buffer, right? So let me run this code. Hopefully it works, because I haven't set up any environment, just clone from old repo. So yeah, first time it will do sync up. It will just get everything ready, whatever you need as an environment, and gives you the output. So you can see it still uses the JDK here, right? And then compile the entire execution model, right? So if you're interested how Scala runs on Java, you can see all the libraries used here, how it works, and those things. So coming back to here, you have list 1, 2, 3. You have got list here, and then we are checking the length of the array. You see 3 here, and then everything we are printing. List buffer we have created as an empty, right? And then we are adding the value to 4. So you can see list buffer value 4. Yeah, so this was basic, very basic on the collection type in Scala. So any questions so far on this?
Chetan, Pradeep here.
Hi, Pradeep.
Yeah. So still I have a basic thing unclear. So why it is better than Java? Because looks like more or less like all the features are available in Java. What makes it different from Java, and why we should go with Scala?
Yeah, good question. As I said, that we are only talking on very introductory about Scala. I'm not confusing with the advanced things that when you, I mean, why you, how it differentiate from Java, or where there's a value with the Scala. One thing is that you see that very popular libraries like Spark and Kafka and Flink, those are very distributed manner, right? When you talk about distributed things, means you run your code on different nodes, means your code is not executing on one machine, that execute on different machine, and then that is distributed and you control that thing. Other thing is that you get an exception handling, not exception handling, but the control over all asynchronous calls happening to different machines, right? That kind of concurrent and parallel execution model, when you want to create, at that time you will need to use Scala than Java.
Okay. So another line, it is using Java JVM itself. So what makes it faster? Like, if any idea?
What makes it faster is implementation, right? Itself makes it faster, which means that like like if you get something which is general purpose for you, like Java, right?
Okay.
Now it's not, Java is not created for asynchronous and parallel computation programming only, right? Because Java is used everywhere. In Android, Java is used for microservices, Java is used for like Windows-based application. You can write kind of, Java is general purpose, right? You can do anything that you want to do with Java, but Scala is specified. I mean, many things you can't do with Scala, what you can do in Java, right? But I mean, Scala is specified for creating a parallel and concurrent application for the enterprise.
Okay.
Like the implementation of the thread that you have in Java, right? We have got here green thread or future or the actor. So I mean, this is a different implementation and a different abstraction of the code base that they have.
Okay. I think when we go along with this training, I think we'll get more clarity. But still, I have some kind of unclear, like why, how it is better than like Java still. Okay. Yeah. Thanks for the explanation. Yeah.
Yeah. Yeah, I mean, once we go ahead, I mean, the functional programming, understanding the functional programming is not even easy. And once you understand, explaining to people is not easy. So, I mean, it takes time to understand that, right?
Yeah, right. Thank you.
Yeah. So let me go back to functions here. Yeah. Fine. So after collection type, we will go to the case class. So I will explain in the sense of other people understand, like Java or anyone else work with object-oriented programming. So I will use those terminology somewhere. So how in Java you create the POJO, right? Plain object for your execution model. You can create the case class here. So case class is like Java. You can map any unstructured type of object with your abstract object type. So you can map that in structure, right? So here I'm creating case class employee, providing two variables here, username and password. Inside the case class, it contains the apply method. So apply method will do initialization of the those two variables inside that. So it has constructor the way you have constructor in POJO, right? But everything in one line. It does everything for you, right? So one way is that you need to write less code than compared to Java, what you write, right? You don't have to create one file of Pojo and have all these things, get a setter method on those things. It does automatically for you inside the case class. And then you create here the main method, and here I'm creating the object of the employee case class and assign the values here, right? How you can access the value, you can use the object and dot the property name. This is a property for you, right? Username and password. And then if you want to have to create new variable, new object, and copy the value from employee object to that, you can use employee.copy, and then you can compare the objects here. So let me execute this. So you can see here employee username is employee123. Let me print the value of assert here. Right, so this comparison has no output. So that does mean both are matching the value of the copy of object 1 and object 2 here. So also you can assign, let's say if you want to set default value here, you can set 1, 2, 3 itself here. And then you can have on implementation here. So, I mean, if you go back in very, very advanced level, you will see that everything looks like function to you, even case class, you can have a function, and then you can define the apply method here. Sorry. So you see the template method for apply. So internally it uses the apply method and pass the kind of construction to that value. So you can redefine the value implementation here with the function, you can have your own business logic and tell that based on which condition it can pass which kind of value and create the object model for you. Next thing that we'll talk about is pattern matching. So functional programming is very popular for doing the pattern matching. So let's say if you have the list, mostly people use list to explain the examples in Scala and Haskell. So I'm using list here to define the collection type, and then we will do pattern match on top of that. So I have got list 1, 2, 3, and then I'm doing pattern match on that. So think like your match element get X, and type can expect anything. When I say anything, you have specific type any. Okay, so you have keywords like anything, nothing, then you have none, right, to accept the value from any abstract type. So I'm going to the method doing well matched element is equal to X match. Now equal to X can be any variable, right? I'm saying match and then saying case. In the case, if I say list 1, 2, 3 means does it match the value with this? If yes, then you will say it matched a list 1, 2, 3. Now you're saying I want to have a condition where it matches a list with only one element and extract the element by decomposing the list. Means only one element in the list I want, and then I don't want to get that, right? So if I pass list of 1, then this condition will be true because list start with the one element and the tail is nil, means there's nothing after that. Same way, if you want to match that list head of the list with the integer, and then you want to integer value 2, and then you want to say there must be a tail of that. So can I get the tail of that? So in the list, if you create the list, if you say the method called head, it will give you the first element, and when you say tail, it will give you the whatever element are there minus head. Okay, so that's terminology here, and you can also access by double colon the head and tail. Here what I'm doing is that to match a list with which has an integer 3 and followed by 4, and there must be other elements into that, and it decomposes a list and extract the rest of the list, including excluding the first two number in the list. So how you can do that, you will say list first element, second element, and exclude that two element and give us the tail. So you say the list 3 for xs means the tail here. You say @ star. When I say underscore star means everything from the tail. Okay, and decomposing a list which has a head and tail, you can say, yeah, there's a list which contains the head, this, and tail, this. So this case will only execute in general where there's a more than 2 element in the list. Now match with any string. So there's a 1 element and it is string. So you can also do matching, pattern matching on type. Here we are doing pattern match on the type like string, but here we are doing pattern match on the value, right? 2. So pattern match has differentiation of type and value here. It's a string with the value this. If you want to check that is a nil, means there's empty list, you can say case nil and empty list here. Okay, so let me execute this. So it matches pattern and only 1 element, and list has 3, 4, 5, 6, 7, 8, 9. You can see here empty list, and in the second last you got, and you have it's a string with the value hello, empty list. Let's go back there. This was empty list, and this also empty list, right? And this is a string value in that. So you can create one function like that and match many other values in between that. And this is a statement. You can have other function here. Now, as I said, value is a function. So if function is a value in the Scala, you can do pattern match based on a function also here, right? So you can provide the function here and pass the value and get immutable output, and based on output you get direction for that case, right? After pattern matching and case class, let's move to the options. So what is option in the Scala? So let's say you think that there's a function which can return two type of value. Either it can return the value as what you're expecting, like integer, and can return you the null value. Now, null pointer exception is what you get in Java, right? Every time you get null, or you need to handle the null value. Now, if you want to overcome that kind of situation and you want to have optional data structure that you don't know, sometimes it might have a value integer, or sometimes it can be a blank. It can be null value, or it can be default value, or it can be no value at all, right? Null Scala Java assigns where there is no value, right? But if Scala says the no value is no value, then why you want to say null, for example? So on that case, you can use option. Now, option is similar, something like, well, optional integers. Let's say you can have option. Sorry, you can have a type option of integer, and then you can say equal to right. So when you have option and the value, what you get is the sum. So if you want to have a pattern match on this or to get the value, you have two things to validate. And you can say get on option to get the value from the sum. Sorry, this should be getting, no. Optional. So when you say optional integer dot get, you get the integer value. Now, if it was null here, you can't have null, but say, yeah, it's immutable, so you can't reassign actually. Let me create something else like, so option doesn't contain the null, but this option of integer can have a null. Now, how you can access that? When you say dot get, you will get a value called none. Or you got null pointer exception because you can't, yeah, this is where you can use pattern match and validate that. So if you use, since this can have a Java JVM keywords to be executed, you can mix up that. But ideally what you should do is that you will say none here. And then if you do this, it still gives you no such element exception, right? But you can avoid the null pointer exception on top of that. So we'll talk about example how you can handle, but the thing is that the option can have two values. One is sum of the value which you define. If you define integer, it can have integer, and other is none value, right? So how you can handle here, that is what we'll see. So when you say convert to integer, method string option of integer, and you have integer value, you use try string to integer. Now see, this can also fail because given the fact if something which cannot be converted to integer, it will fail, right? ABC will not be able to convert to integer. So you have the integer value and then you will map it on top of that. Now here you say case failure exception, then you will say println this to this. So here by default you pass the value called none. As I said, option can accept the none, and or it can accept the real number of sum. So on case success number, we are saying successfully converted string to integer and then pass the value called sum of number. So here there are no chance that you will get null pointer exception, right? Even the value is null or something like that. Because you anyway say that if there's failure, then you pass back the value called none. But it won't interrupt your execution text state trace anywhere. So here I'm creating the string value 10 and then saying convert to integer string value. Now also you can pass default value. Let's say you try to get and you don't get what you really want, and then you say or else define the 0. String invalid value hello, and then if you don't get, define 0, right? So if I execute this, you will see successfully converted string 10 to integer and cannot convert hello to integer, returning default value 0, right? So that's where you get here. Now you can play with option a bit more complex way and then get the way you want to deal with option. So if you see here how you can pattern match that, let me write some code. Number option of integer, okay, and then let's assign here option of 5. Now you know this number is sum of and then you say sum of x, and then you say print ln, and then you can say then define what you say print ln. This is non-integer. So in this way, you can handle the pattern match. If you say case underscore, now case underscore, well, you can return anything. You can also return none here back, right? If you think this is something which is unexpected for you. So underscore is a default value, whatever comes, right, in Scala. So going back to exception throwing. Now this is something like Java, which you do it, right? Which supports here also. Now, if you are create file and then you see the file name ends with Scala, then you so illegal argument exception, same way, throw new. You can also have a null if you write code like Java. So this is entire file like Java you write, right? And then you have file data and then have case catch, and then you provide a case for the first exception and second exception that you have, and then you go ahead and that, and then you have a method, you have try catch, and finally the way you want. So this also works, but this is not functional programming practice here. Let's go to transformations. What kind of transformations are there? And then we'll switch back to functions. We have 10 minutes, but let's see how much we can cover. So the transformations in Scala means you change the data structure by applying some transformation on top of that. Predefined transformations you get here, and this all transformations are tailed recursion, means you can use single frame of the state to do the operation at the end, right? So you don't have to write all tailed recursion implementation. All this function which you can see map, reduce, and fold left are by default tailed recursion. In functional programming, you will not use for loop, you will not have while loop, you will not have those looping structure because everything is function here, right? That is what you will see as a difference here. Now, I want to, so that we have integer list 2, 4, 1, 3, and then sum using reduce integer list dot reduce, and then it can have two variable. One is element, and second is an accumulator, which can hold the value of each iteration, right? And at the end, you combine that both. You have map, you have list here, you want to do map, and this is map dot group by element of first here, because this is inside this tuple, list of tuple, right? So you can access tuple value by dot underscore 1 underscore 2 and like that. And now we are doing fold. So I mean, you know, like when I'm talking about you don't have while loop, you don't have for loop, then what you have, you need to anyway iterate the, I mean, why we use the looping structure to iterate the collection types, right? Any collection type we get, and then do operation on that collection type and transform that back to the original state which we want, or to the revised version of the object that we pass to the looping structure. So now we have fold 0 element intermediate sum. You can define any variable here. This is, I'm just using element or intermediate sum, right? And then you can say intermediate sum plus element here. Now there's something called for left. We start from the left, you provide default value, and it can go till the value you have. This is undefinite function compared to for is definite function, means it will traverse all the element it has, and this will go back to the start from the left, and it will go till, you know, wherever I mean, this is scalable because it uses the tail recursion, where for will not use tail recursion. So this is this won't throw you take over forever. And then you have functions like max. So I mean, you might see people are writing code like each word, and each word is function. So you see here that ACC accumulator and the element, and then you have accumulator and max element, right? So here I'm not defining like bracket or curly braces and then pass the value like that, it understands that I want to find maximum from accumulator for each element, right? And then pass the value back to accumulator, and then it will be given back to max using for left. So you get maximum value from the collection type called list. So the performance of doing for left and performance of doing for loop is where you have differentiation that you see that which is faster. For left will be winner over there. And you have integer list. I mean, it's not like you don't have methods like dot list dot sum or like that, which works in Python way. You have integer list dot sum, right? But I mean, this is to only find the maximum. That doesn't mean you always want to find the maximum, but you want to have your complex operation here, right? You want to do some database decomposition and get the value for each value that you have list, and then collapse internally, and then come up with any other type of data which you want. So you can define everything in that function. So you can actually call your own function then having max, which can accept the value from the list here element, right? You have filter. So when you want to have a filter condition, let's say integer list dot filter, you say element where element is less than 3 and keep the written back as a list here, right? So this is what you can see, sum, stan, group data you have here. You have got maximum value for, got integer list sum using for 10 using the API 10 you have got here. So we are saying that whether you use with a normal API, Scala is 10, and whether you use with the for left, you get the same value here. List containing values which is less than 3 is this list 2 3. Now here we are just defining this condition as a predicate element less than 3, but you can have your own function, can do anything whatever you want to do, and the filter out based on the output that your value returns from that function, okay, and that can return you the list here. So you can avoid many other long line of code which you have. Oh, my mistake, I have directly gone to advanced transformation then going to simple transformation. Yeah, so let's see the simple transformation after seeing the advanced transformations. So simplest are, you create the list, you have the map, and you just change the value of the map by saying element +1 and return the new list here. So if you want to iterate, you can iterate with the map. You can also use kind of loop, for loop, we call it for each, right? But you can avoid as much as possible. And this is where, means this is mutable. Okay, I'm just giving example. If you want to do something like that, you create empty list and then you say copied list plus, I mean, this is the one which adds the value to that, and then assignment operator of element here. So the colon plus can add the value to the existing list, but when you say equal to, means you want to add to the entire whatever it has earlier, and then add the value to that. This is equal to plus equal to, which you do in Java kind of programming language, right? You can say take 2, so it will give you 2 elements from the list. You can combine the list. So how you can combine? You can do map on the list of list. So when you have different collection of type, like collection of collection nested structure, and at the end you want flatten output, right? So then you can do map, and anyway, this will give you the output like nested collection of the list. Now when you say flatten, it will flatten that out and give you one list here, right? And you can directly do flat map. Both are equal. Map and doing flatten or doing the flat map are equal. You will hear flat map more often in functional programming language in Scala, because you compose and you decompose, where flat map is very helpful to you. And then you can do group by and saying x to lower map y dot underscore 1 y dot underscore 2 and length. So you want to create the tuple, sorry, list of having this element called how much is the each word contains here. So let's say if you go here, we have to print this. Yeah, so what we are saying, each word is coming how many times in the sentence. So T comes how many times, H comes how many times in the sentence that you define with this map, right? So you can do like group by, convert to lower, and map each element. And first element is itself, and second is the length of that across the entire line. Okay, and map is this when you create the map. That iterates each other, and group by with anyway create the group of same kind of element and give you to you, and then you can just say from that tuple that tell me the first is the key and the length of that is the what we can tell is a number of occurrence to the sentence, right? Rest you can see that integer and gives you when I copy this, you have the entire list created from the copy, and then flatten map and the flat map both look similar to you. So whether you do map.flatten or you do flat map, both are similar for you, right? Um, are we running out of time or we have 10 minutes? I think.
Team, is it okay if Chetan continues for 10 more minutes and finishes what he's trying to complete?
Yes, Emily.
Yes.
Thanks.
Sure. So we'll go to implicit. What is implicit in Scala, right? So, I mean, implicit is a keyword, can be used for implicit class, implicit method, implicit variable, um, which means that the scope of and the context of the any value is available with that area, right? Why I'm saying the value? Because in Scala everything is value. Class is a value, object is a value, function is a value, right? And then you have a variable as a value. So you can say the value is accessible to that specific context. So this is formal method called case class, source string, and then as I said, you can define the method in that case class also. In this case class is like Pojo, but you can have a method with how it can behave. And saying syntax, you have a text here, and then you say println what you want to print that. And then I'm saying communicate form one, text is the variable, and there's implicit as source, and send.text. Now this context of the s is available as implicit here, right? Now this method becomes implicit value taker. So when you call and when you pass something to that, you should have implicit value. That's why in the main method I have implicit val default source, and then saying source means this class and passing default source. And then I don't have to create the object of this case class and the call, because I have this implicit available in my context of the main class, main method. So I can directly call communicate form one and pass the value whichever I want, right? And then I can new source, new source. And then remember, you can pass the value argument as something like, once you are done with this method, and then you're saying that, oh, this method returns something inside the method, but I want to pass new source to that method. How can I do that? So you can pass this, because the communicate form one can accept one text value, but it can accept the value called t, for example, called source here. You can, this implicit pass, this looks like two method, right? So two argument to same method, right? But this can be a function. So you can pass the function value, like I'm passing here new source as a value here. So you can do this way also here. So that's implicit, but implicit is going away from Scala 3. So as far as you use Scala 2, you have implicit. Otherwise, you don't have implicit in Scala 3. And Scala 3 is down the line, end of 20 or start of 2021. I have left with these functions. We'll talk before that. Let me go to log parser. So you can do file handling also here in Scala. One example, let's say you have the directory path. Here you have all the files, and you have a method called getCSV and provide path, and that return the list of strings. So what you are doing, you are saying, can you give me the list of files in the form of path in a string where the extension is CSV, for example, right? So you will have value directory new file where files list string empty list here, and then you say file directory exists, directory is directory, and then you say files directory dot list files dot filter file dot is file, and file dot get name ends with CSV, and then you map it. For each file, get the absolute file dot toString, and then you convert to list here. So it will be list here for you, right? Now, I'm not sure how many CSV I have, but let me run the code. This is my Ubuntu path, won't work with. So, yeah, we have this many CSVs here. Now, you can do in different ways also here. You can say, well, I'm just giving X files is equal to if exist, okay? And then you say this one, right? You don't need to have a curly braces and those things here. You can just write in this way. And then you say X files is any. The only difference is that Scala thinks that if this is not true, then what will be the case, right? Then you have to have else condition here. So then you will say else kind of empty list. So now you see X files, it tells you the list of string, right? So let us print X files. Also, you can't print after return. Yeah, one thing, you don't have a return keyword here. Whatever you use the last line of the code as a variable is by default return, okay? So you see other things is printed like that. So again, you can have that as function and you can just make it pattern match the way you want, right? Now going back to higher order function, what you have, and then we'll have tail recursion example and then currying example. How we can do, probably we'll content currying in next session, but let's talk about higher order function. So the higher order function is that the function which takes function as a parameter for you. So let me create a function called sum. Some programming language also tell it as a anonymous function. Like Haskell, they call it anonymous function, which is higher order function for you. In Scala, you have sum. So where you can use higher order function. So how many higher order functions are there? In Scala, by default, higher order functions are map, flat map, reduce, all these transformation functions that we have seen, simple as well as advanced transformation functions. Everything is higher order function, means everything can contain the function, can take as a function and can return as a function. So think in this way, the higher order function can take it as argument as a function and return the function to you, which help you to compose the function, right? And second thing, when you create anonymous function that is polymorphic in the Scala, means the context differs compared to Haskell and Java when I talk about higher order function and the anonymous function. But let's talk about how we can create that. So sum I have f as a variable and it takes tuple integer, and then I'm saying that this can return the integer and can take two more value here, x and y, and then return the integer back. So here I'm returning f, x, and y, but this is also function which we are returning back. Function returning function as a result. So you can have say something as a function, where you have prefix as a string, and then you can return string as that, and this can again return the string, and that can have a name and string. It becomes very complex because itself string is a function in Scala, right? Technically, if you go inside the code, it is typed, but everything is a function, and function has a value. Everything is a lazy, so it becomes a bit complicated when you compose a bit more than what is expected here. And then you return prefix plus name. Now this is a string because it at the end returns the string for you, right? So when you execute the code and debug, you will see that how it is working. Sum of integer, you are saying sum of x and y, where you have to do x plus y, and you are passing the value 10 and 20. Sum of squares of integer, you say sum of x and y, and then you compute here the square and plus square, and then you pass 2 and 3. When you have it is all passing the value to the function. So the greeting is, yeah, this is also interesting, that when you assign the value to the return value to the function, say something is a function, you pass hello and you assign to greetings, right? Now you can call this variable as a function because everything is a function, right? So I'm calling greetings and pass the Harris here, calling greetings and pass the Chris, right? And then passing the axion to the greetings value. So sorry. So you can treat function as a value, and you can treat value as a function also. So let's move back to tail recursion here. So mainly all these higher order functions available in Scala are tail recursion. Means to do the final operation, it uses the last only one stack frame to compute that. So you won't have a stack overflow. You can also optimize the way you want inside that. If you want to do normal sum, you will have this normal sum and pass the list of integer, return the integer, and then if the xs dot is empty. So as I told you that if a list is empty, you will have 0. Otherwise, you will say xs dot head and normal sum. So you are having the recursion method here. You call the same function itself here, and then you pass the tail, and again tail will be adding the value to xs dot head here, right? Now, when you want to do tail recursion, you will add the annotation called tailrec here, and then you will have one more variable called accumulator, as we have seen in left fall and fall method. And then you will do pattern match, integer match here. Case is nil, means it's empty. Then you will pass the value default, whatever it is. Otherwise, you will say case x means the first element and the tail, and you pass tail to the same method called sum. And accumulator, whatever you have, you will just add the value called x, means the first, the first value of each iteration should be added to the sum, right? And give the tail back to the method. So now you see here, you will see that how many times iteration is happening, how it's getting reduced. So when you execute this one, a normal recursion method, it goes like first this way, then second step, third step, fourth step, and compute that. Here it calls in 3 steps and give you the same output to you, right? When you have a larger set of data, when you now think like when you work with big data, now think like when you work with the largest amount of data set, when think about when you distribute to multiple workloads, right? Now rather you have your own implementation in Java, or you can use each method which is by default type safe and tail recursion and the performance optimized, right? That's the reason you can have benefit in Scala. I think we can talk later on currying function, right? We are left with currying. We are left with nothing, just left with currying. So we'll check.
Chetan, I think we can cover this in the next session. Santosh has already left, and I think rest of the people also will be having something. So next week, we'll set up this again on next Wednesday. I hope people will join in at that late. I'm extremely sorry. It's because of the time zone difference. Chetan is in Canada right now. Thank you, everybody. And thank you so much, Chetan, for conducting this session. Thank you so much.
Thanks for joining, everyone. And I will share the code with with
Chetan forgot my name.
yeah, Neelam, and then Hemali. So it would be said across to with everyone. Okay.
Sure. Thank you so much.
Thank you.
Yep, thanks, Bhutan.
Thanks.
Bye-bye.
Bye.